Hello everybody, welcome into another lesson. So as of today we are on the final 5 lessons. We are going to shift into quadratic equations. Today's will be in particular about quadratic equations with perfect squares. In the coming lessons you'll learn about completing the square to solve a quadratic equation. We'll even introduce the quadratic formula. We'll talk about the discriminant, and then for the final lesson, we will end up bringing all methods of solving quadratic equations on the table. For the final lesson, you'll be given a quadratic equation. You'll have to decide which method is more appropriate to solve the particular equation in question. So that's where we're at right now. We've talked about quadratic equations previously in this course involving factoring methods of how to solve them. You've had it where you'd have a quadratic equation, you would set the right side equal to 0, or if it wasn't equal to 0, you'd somehow make it equal to 0, and then you could factor it. Well, the methods I'm going to teach you can work if the equation is factorable or even if it's not. Some of the equations we're going to do coming up are not factorable. So that's where other methods will come into play. So for the next few lessons, we're not going to use factoring at all. Like for example here, we have x squared equals 64. Well, a basic way to do this is probably the easiest method, is if you have both sides that are perfect squares. You have x squared equals 64. If we recall, you would just take the square root of x squared to get x by itself. So we'll just do that. You'll get x. That'll equal plus or minus the square root of 64. Because whenever you have the square root of a variable equation, you take the square root of the x squared, right? But on the right side with a number, you have to take both plus and minus the square root of the number on the right. So this would mean x is equal to both plus and minus 8. And you could actually leave your solution written like that. You don't have to list two separate solutions. X equals plus or minus 8. And if you put either negative or positive 8 in, you'll get positive 64. So that is that's one example. Now, what about if I have something like this? I have y minus 7, that quantity squared equal to 0. So now I don't just have the variable by itself, I have something that's being subtracted from it inside the quantity. Still the same idea. I'm going to take the square root of y minus 7 squared in order to get y minus 7 by itself. So let's do that. You'll get y minus 7 is equal to both plus and minus the square root of 0, which means y minus 7, well, plus or minus 0. 0 is the only number that's not either positive or negative, it's just 0. It would just be 0 regardless. And then, of course, you would just end up getting y equals 7. That would be the only solution. But when we get to Algebra 2, you're going to see that, yes, it looks like one solution, but it's actually one solution occurring twice. This 7 actually occurs twice in the quadratic equation, and when you go to graph something, if the same solution occurs twice versus only once, it looks different on the graph, which we'll get more into that at that time. Right now, just know that this solution's actually occurring twice, but you only have to list it once, of course. Okay. Let's see. We have t squared equals 100 over 169. So we have t squared equals 100 over 169. So again, we want to get t by itself, so take the square root of t squared. You will, in fact, get t. That would be equal to the square root of, well, actually, I almost made a colossal blunder. It's supposed to be plus and minus the square root of 100 over the square root of 169. Well, to take this a step further, t is still equal to plus or minus, but the square root of 100, well, that's 10. Over the square root of 169, that's 13. So t is equal to plus and minus 10/13. That would be your answer for this. Now how about this one? A squared equals negative 9. A squared equals negative 9. Well, still the same process. You're going to take the square root of both sides. Square root of a squared, that just gives you a. That'd be equal to plus or minus the square root of negative 9. Well, we've just hit a snag here. We have a square root of a negative number, and in the real numbers, which is all we're dealing with in this course, there's no solution. You can't have a square root of a negative number. The reason being is because there's no number raised to the second power that gives you a negative number. So for this, there is actually no real solution. That's how you would word it. There is no real solution to this problem, because you have the square root of a negative number. Now in Algebra 2, when we talk about imaginary numbers as part of the complex number set, there is a solution then, but we're not there yet. Alright, how about 3x squared equals 108? Alright, so we have 3x squared equals 108. Well, first thing you want to do, of course, is you want to get that x squared by itself, so divide both sides by 3. If you do that, you get x squared is equal to 36, which is now something we can work with. So we want to solve for x. Take the square root of x squared, you do get x. That's equal to plus and minus the square root of 36, which, as we know, square root of 36 is 6, so x is equal to both plus and minus 6. That'd be your answer for this. X equals both plus and minus 6. Alright, let's see. How about one like this? We have 6x squared minus 18 equals 0. As you know, you could factor this. You could factor out the 6 and then try to take a difference of 2 squares as the factor. But we're not factoring at all in today's lesson. Not at all. So what you're going to do is try to get that 6x squared by itself. So add 18 to both sides. If you do that, you get 6x squared is equal to 18. Now we want to just get x squared by itself. So if we do that, you'll get x squared is equal to 3. And then x would equal plus and minus the square root of 3. And as we know, the square root of 3 is not a perfect square. So that's your solution. X equals plus and minus the square root of 3. That's all you would have. So this lesson today is probably the easiest one we're going to do with quadratic equations. Alright, let's see. We have 7m squared minus 42 is equal to 0. So we have 7m squared minus 42 is equal to 0. Well, of course, get that 7m squared by itself, so you have to add 42 to both sides. If you do that, you'll get 7m squared is equal to 42. Now you just want to get m squared by itself, so you divide both sides by 7. If we do that, you'll get m squared is equal to 6. Now take the square root of m squared, you'll get m is equal to both plus and minus the square root of 6. And 6 is not a perfect square, nor are any of its factors, so m is equal to plus and minus the square root of 6. Alright, let's see. 4y squared plus 7 equals 19. Alright, so we have 4y squared plus 7 equals 19. Well, I'm going to say let's get that 4y squared by itself, right? So that means we need to subtract 7 from both sides. If we do that, you'll get 4y squared is equal to 12. Now just get the y squared by itself. You divide by 4 on both sides, you'll get y squared equals 3. So take the square root of both sides now, you'll get y is equal to plus and minus the square root of 3. And that would be your answer. Y is equal to both plus and minus the square root of 3. Good one. We have x plus 6 squared. The quantity of x plus 6 squared this time is equal to 16. So before we talked about this method, the old way we would do it, and you can still do it this way, is you would expand this out as a perfect square trinomial or binomial square equal to 16, and then you would subtract 16 from both sides, make the right side equal to 0. Good news is you don't have to go through that trouble. There's a much simpler way. The goal is still get that x plus 6 by itself. Get that x plus 6, right, by itself. We have to take the square root of both sides. If we do that, you'll get x plus 6 on the left. That would be equal to plus or minus the square root of 16. Which means you'll get x plus 6 is equal to plus or minus 4. Well, now the goal is to get x by itself, so we have to subtract 6 from both sides. If we do that, you'll get x is equal to negative 6 plus or minus 4. Which means we're going to get two distinct solutions here. If we take x is equal to negative 6 minus 4, you'll get x is equal to negative 10. If you take negative 6 plus 4, you would get negative 2. So therefore, x actually has two solutions of negative 10 and negative 2. That's exactly what you would get. So negative 10 and negative 2 would be your solutions to this. Alright, let's see. We have the quantity of y minus 6 squared is equal to 13. So, we've been given the quantity of y minus 6 to the second power is equal to 13. Well, it's especially for one like this, as you're about to see, we should be thankful we're not expanding this out, and we're just simply doing a perfect square method, because you want to take the square root of y minus 6 squared to get y minus 6 by itself. If you do that, you'll get y minus 6. That would be equal to plus and minus the square root of 13. Well, now you just want to get y by itself, so you have to add 6 to both sides. If you do that, you'll get y is equal to 6 plus and minus the square root of 13. So that's really two different solutions. It's just the way it's listed, it might look like one, but it's two different solutions because you have 6 both plus and minus the square root of 13. So the solution to this one is y equals 6 plus and minus the square root of 13. That's as far as you can get with it. Yeah, and you will get results like this. You'll get it when we complete the square, when we have the quadratic formula, and we're going to have all kinds of stuff. So we'll have fractions even at some points. All right, let's see here. we have y plus 2, that quantity squared, is equal to 12. So we have y plus 2, that quantity squared, is equal to 12. Well, still the same idea. Take the square root of both sides to get y plus 2 by itself. So yes, we'll get y plus 2 by itself. That would be equal to plus and minus the square root of 12. Well, we know the square root of 12 has at least one factor that's a perfect square. You'll get y plus 2 is equal to plus and minus the square root of 4 times the square root of 3, which we know the square root of 4 is 2. So y plus 2 is equal to plus and minus 2 times the square root of 3. You always want to have this in simplest form. It's improper form to leave it as the square root of 12. You want to put the answer, you want to put the square root in simplest form whenever you can, as we did with the square root of 12. So now we have y plus 2 equals plus or minus 2 times the square root of 3. Now we just need to get y by itself, so you subtract 2 from both sides. So you'll get y is equal to negative 2 plus and minus 2 times the square root of 3. And that would be your answer for this. Y equals negative 2 plus and minus 2 times the square root of 3. So that wasn't too bad. It looks bad, but it's really not. All right, let's see. We have x squared plus 6x plus 9 is equal to 16. Well, the old way would be to subtract 16 from both sides, get the right side equal to 0, and we would have a factorable form. But we're not factoring today. No factoring allowed today. Well, at least not for the whole equation. But we know x squared plus 6x plus 9, that's the exact same as x plus 3, that quantity squared. That would be equal to 16. Right? X squared plus 6x plus 9 turns into x plus 3, that quantity squared. Because we're trying to do today, we're only doing this as the two squares, two perfect squares equal to each other. So x squared plus 6x plus 9 turns into the perfect square of x plus 3. Alright, so now we've got our perfect square. Now we just want to get that x plus 3 by itself, so take the square root of both sides. You'll get x plus 3 is equal to plus and minus the square root of 16, which means x plus 3 is equal to plus and minus 4. Well, now we just want to get x by itself, so we got to subtract 3 from both sides. If we do that, you'll get x is equal to negative 3 plus and minus 4. Well, we can add and subtract 4. Let's see. If we do negative 3 minus 4, we get x as negative 7. If we do negative 3 plus 4, we get x as positive 1. So the two solutions to this equation are x equals negative 7 and positive 1. Both of those would be the solution. Alright, let's see. We have r squared minus 22r plus 121 is equal to 4. So we've been given r squared minus 22r plus 121 equals 4. Well, r squared minus 22r plus 121, to get a perfect binomial square, that factors into r minus 11 to the second power. That would equal 4. So now we have the quantity of r minus 11 to the second power equal to 4. Now we just want to get r minus 11 by itself, so take the square root of both sides. You'll get r minus 11 equals plus and minus the square root of 4, which means r minus 11 equals plus and minus 2. So now we just want to get r by itself, so you have to add 11 to both sides. If you do that, you'll get r equals 11 plus and minus 2, which means we'll have two solutions again. You'll get r is equal to, let's see, 11 minus 2, that's 9. 11 plus 2, that's 13. So r is going to be equal to both 9 and 13. Those are the two solutions you would end up getting to this equation, 9 and 13. All right, a couple fun ones here. We have 1/5 x squared minus 5/49 is equal to 0. So we have fractions involved now. It looks intimidating. So we have 1/5 x squared minus 5/49 equal to 0. Well, we're only doing this as perfect squares on both sides. So that means you want to get that 1/5 x squared by itself. So add 5/49 to both sides. What you'll end up getting is 1/5 x squared is equal to 5/49. Now we just want to get the x squared by itself. So you have to multiply both sides by 5. If we do that, you'll get x squared is equal to 25/49. So now, of course, we want to solve for x, so we got to take the square root of both sides. If you do that, you'll get x is equal to plus and minus the square root of 25 over the square root of 49, which, as we know, we're going to have the square root of 25 is 5 over the square root of 49 is 7. So the answer you get for this is x is equal to both plus and minus 5/7. That's the answer you would get. All right. Let's see, I only have roughly a few more here. So we got 1/6 x squared minus 4 equals 5/6. So this is a fun one. We have 1/6 x squared minus 4 equals 5/6. Well, first, let's get that 1/6 x squared by itself. We have to add 4 to both sides. If we do that, we'll come up with 1/6 x squared is equal to 5/6 plus 4. Well, to make 4, let's see, to have a denominator of 6, it'd have to be 24. So what you'll get is 1/6 x squared is equal to 5/6 plus 24/6, which means now that 1/6 of x squared is equal to 29/6. Well, we just want to get x squared by itself now, don't we? So you have to multiply both sides by 6. If you do that, you'll get x squared is equal to 29. So x squared equals 29. Now we just want to solve for x. We take the square root of both sides. You'll get x is equal to both plus and minus the square root of 29. Well, 29 is not a perfect square, nor are any of its factors, which are only 1 and 29. It's a prime number, so x is equal to both plus and minus the square root of 29. That would be your answer. Alright, I think there's 2 more I'd like to do, then we're done. Okay, so we have y minus 3/7, that quantity to the second power is equal to negative 8/9. Well, here's a solution already. I'm going to tell you why this has no solution, because you're going to end up taking the square root of a negative number. We can stop right there. There's no real solution, because if you have a negative number on the right-hand side, you're going to have no real solution. So, because you can't take the square root of a negative number. So that one's already done. That's going to save you a lot of trouble without having to do all the square roots and all that. That's a big time saver. And I'm all for keeping it simple and not trying to overly complicate it. But last one here, for real. We have z minus 3/5. That quantity to the second power is going to equal 7/16. Alright, so we have another fun one here. So we have z minus 3/5, that quantity squared is equal to 7/16. Well, let's start by taking the square root of both sides to get z minus 3/5 by itself. So now we'll have z minus 3/5. That's going to be equal to both plus and minus the square root of 7 over the square root of 16. Which we know that the square root of 16 is going to be equal to 4. So we get z minus 3/5 is equal to plus and minus the square root of 7 over 4. Now the goal is we want to get z by itself. So z is going to equal 3/5 plus and minus the square root of 7 all over 4. But we're not done yet. We have 2 different denominators. We want to get the same common denominator. I think it's obvious it's going to be 20. 20 would be your common denominator. Some teachers will take an answer like this, but a lot prefer the same common denominator. So if you multiply that 3/5 each by 4 in the numerator and denominator, z would give you 12, you'd have 12/20ths, but you can write this as one denominator. We're going to make the whole denominator 20, then multiply your square root of 7 by 5. So what you would end up with is 12 plus or minus the 5 times the square root of 7 over 20. If you wanted to get the same denominator. Some teachers will take this answer, but some want it as one denominator. So you would end up getting 12 plus or minus 5 times the square root of 7 over 20. And I suppose this way would actually make it easier to enter into the calculator than it would this. So that would make sense. Okay, so that's it for solving quadratic equations with perfect squares. Next lesson, we're going to solve quadratic equations by completing the square. I'll teach you that method. So I hope everyone has a good day. Take care.